Alright. Can you explain in as much detail as you can how water changes from solid to liquid and from liquid to gas?
Changing from a solid to liquid and a liquid to gas are what we call phase changes in chemistry, and it requires heat. If you're changing up the ladder from solid to liquid to gas, and then a loss of heat must occur for it to go from vapor to liquid and then liquid to solid. During these phase changes, the molecules will, different things will happen to them. For instance, between solid and liquid, the intermolecular forces are loosened. There's more randomization that occurs going from solid to a liquid. And then going from a liquid to a vapor phase, you're breaking intermolecular forces entirely. Things like hydrogen bonding, dipole forces, and ion dipole forces are broken for the molecules to go to the vapor phase.
Okay, and what is the difference between, say, water, like a cup of water sitting on a table, evaporating at room temperature, and the phase change of evaporation when boiling?
Quite literally, there is no explicit difference between the two. It is still a phase change from a liquid to the vapor phase. Intermolecular forces are still being broken. When you're thinking about evaporation, it happens naturally through what's called vapor pressure. The lower the intermolecular forces, the higher the vapor pressure. The higher the intermolecular forces are, the stronger they are, the lower the vapor pressure. So water will evaporate over a period of time based on the strength of the intermolecular forces. Something like acetone will evaporate much more quickly because it has a weaker amount of intermolecular forces in that substance. The same thing goes with boiling. It requires more heat to boil water and to convert it all to the vapor phase because of the strength of the intermolecular forces found in water, primarily hydrogen bonding.
Why is energy required for water to go from solid to liquid or from liquid to gas?
Energy is required to go from solid to liquid in order to cause the randomization of the molecules. Intermolecular forces are not broken in that case, so the amount of energy required to convert from solid to liquid is lower than it would be if you converted from liquid to gas. When you're converting from liquid to gas, as I mentioned before, you're breaking intermolecular forces. In this case, hydrogen bonding is the strongest found in water, and so it would be higher. In this case, 40.7 kilojoules per mole for water going to the vapor phase, and then 6.01 kilojoules per mole to go from solid to liquid.
Right, and you said the intermolecular forces are what holds the water molecules together. Can you elaborate on what those are?
Intermolecular forces are like, they do the same thing that an interstate does. When you're traveling on the roads, interstates bind different states together through that interstate system. Intermolecular forces then therefore bind different molecules together. So within a molecule, a single molecule, there are three different types of bonding that we typically discuss. Those are covalent, ionic, and metallic. But when you're talking about two different molecules sticking together, as would happen if you're forming a liquid or a solid, then it's intermolecular forces that govern how those molecules stick together. And then again, as the types I've mentioned before, hydrogen bonding, dipole forces, and ion dipole, and London dispersion forces are all a factor there.
Alright, and we did have one bonus question. Can you explain why hot water freezes faster than cold water?
Can I explain why hot water freezes faster than cold water? Mm-hmm. I would like to see a Mythbusters episode on that very topic, because it's a numbers game. So if you have water at 60 degrees Celsius, for instance, which is in the liquid phase, you would have to cool that water down, meaning loss of heat. If you're thinking about thermodynamics, heat would have to go from the system, which is water, to the surroundings to achieve 0 degrees Celsius, where it might freeze. And then a further 60.01 roughly kilojoules per mole would then have to be lost to convert all of that sample into the solid phase. So if it's a numbers game, it tells me that the colder the water is at the starting temperature, the easier it would be to freeze, or excuse me, the less heat would have to be lost to freeze that material.